Okay, so we have been talking about various equations of different lines. We are now going to dive into equations for parallel and perpendicular lines. So if you did the video from yesterday and if you did the Desmos activity, you should remember that parallel lines are lines that never intersect. They're never going to cross each other. Okay, parallel lines never cross each other. The other thing that we know about them is that their slopes are the same. Okay, parallel lines never intersect and their slopes are the same. Perpendicular lines, on the other hand, are lines that do intersect. At a 90-degree angle, right? They intersect at a right angle. And then what we know about these slopes is that their slopes are opposite reciprocals. Meaning that they are opposite and then flipped, right? So if I had a slope of 2, the opposite reciprocal of 2 is going to be negative 1/2. So perpendicular lines, opposite reciprocals. So we talked about standard form a little while ago. One of the most important things, the thing that we look at with parallel and perpendicular lines are the slopes. So like we care about slope. And so standard form, if you remember, is ax plus by equals c. So the first way that we could figure out slope of an equation in standard form is to rewrite it in slope-intercept form. Would help if I spelled right. Intercept form. So solve for y. Get this out of the way. Solve for y. Okay, that's one way. The second way that we can do that, if you remember, we used standard form to talk about our x and y intercepts. We used it to find our x and y intercepts. So our x-intercept was c divided by a, y-intercept was c divided by b. I have another shortcut that I can use for finding slope of something in standard form. And that shortcut is opposite a over b. So for example, in this case, I have 2x plus 4y equals 12. Well, my a value is 2, so the opposite of 2 is negative 2. My b value is 4. So the slope of this line is going to be negative 1/2. Okay, so that's in standard form. Slope-intercept form we're used to, right? That's y equals mx plus b, where m is our slope. So what's awesome about slope-intercept form is it just tells us our slope right away. We don't even have to do any math. So the slope in this example, right, m equals 4. Our slope is just 4, and that's it. Okay, so slope matters. We have to know how to find it. Okay, so what we're going to do here is we're going to look at these 4 lines that we have, and we're going to figure out which lines are parallel and which ones are perpendicular. Okay, so we could do that by looking at the slopes, right? I've got a slope, let me make this bigger. I've got a slope here, got my, I don't like that. I wanted to highlight it, but it doesn't look good. Okay, I've got my slope here, got another one here, another one here, another one here. Right, so I could look at the slopes and I could figure out which ones were the same. And I could do that, right? H of x, the slope for that one's going to be negative 2. For f of x, the slope is going to be a positive 2. For j of x, it's also going to be a positive 2. And then for g of x, my slope is 1/2. So pretty clear to see, f of x and j of x have the same slope. So I'm going to write something here, and then I'm going to explain it in a second. F of x and j of x. Okay, these two squiggly lines in the middle here, or the two, not squiggly, the two lines right here, tell us that it's parallel to. Those mean parallel to. So f of x is parallel to j of x. That's what that tells me. Then I can also look at, let me use a different color so we can see the difference. 1/2 and -2 are opposite inverses of each other, so that means that they're perpendicular. So h of x, and I'm going to do a similar thing with the symbol here, and g of x. Okay, so this says h of x is perpendicular to, says that h of x is perpendicular to g of x. And these make sense, right? Because over here, for parallel, these are two parallel lines, right? So that tells us, oh, these are going to be parallel. The perpendicular to symbol is an upside down T, which are perpendicular, right? So they're pretty intuitive with what we're talking about here. Okay. So now we're going to look at writing equations for parallel lines. So write an equation of a line that passes through the point 3, 1 and is parallel to the line y equals 3x plus 1. So I've got a couple triggers here. First one is parallel. When I know that I'm doing a parallel line, I want the same slope. Okay, so I'm going to look at the line that I'm working with, y equals 3x plus 1. Well, it's in slope-intercept form, right? So right away I know that my slope is going to be 3. The point I'm working with is 3, 1. So my x sub 1 value is going to be 3. My y1 value is going to be 1. Now I can just use this with point-slope form, right? So y minus y1 equals m times x minus x1. Just going to plug it in. Y minus 1 equals 3 times x minus 3. Take my 3, distribute it to both places. I get y minus 1 equals 3x minus 9. Add 1 to both sides. I'm left with y equals 3x minus 8. Y equals 3x minus 8 is a parallel line to y equals 3x plus 1. Okay, let's go on to the next page. So slope's important when we're talking about perpendicular and parallel lines. And so we are going to figure out which are perpendicular and which are parallel based off of the slope that we have. So slope for line A, y equals 2/3 x plus 3. This equation is in slope-intercept form. So I can just look right away and see, oh, my slope is 2/3. These other two are both in standard form. So I'm going to remember my standard form is ax plus by equals c. So for line B, I need opposite a over b. Opposite a is going to be a -3 over b is 2. My slope for line B is -3 over 2. Okay, and then for line C, we're going to do the same thing. It's still going to be opposite a over b. But something that you have to pay attention to, right, is with my a value is x, right? With my b value is y. So here I have 3y minus 2x equals negative 9. Well, my a value, it would be tempting to say that it's 3 because it comes first. But my 3 is paired with my y. So this is actually my b value. So my a value is negative 2. So the opposite of negative 2 is a positive 2 over my b value is 3. So now I'm going to look at what patterns I have. So parallel means that their slopes are the same. So it looks like to me that line A is parallel to line C. And then perpendicular lines are opposite reciprocals. And so since A and C are both parallel, they're both going to be perpendicular to line B. So A is perpendicular to line B, and line C is also perpendicular to line B. Okay? We've done parallel lines, now we're going to look at perpendicular lines. Perpendicular means that I'm going to need the opposite and flipped version of the slope that I'm dealing with. So the slope of my first equation, y equals 4x plus 1, is just 4. So that means the slope of my second line needs to be opposite and flipped. So opposite would be negative 4, flipped would be a negative 1/4. And then the point that I want to work with is 4, negative 3. So my x value is going to be 4, and my y value is negative 3. Now I have everything I need. I'm just going to plug it into my point slope form. So y minus negative 3 equals negative 1/4 times x minus 4. When I subtract a negative, it becomes a positive. Also need to distribute my 1/4, my negative 1/4 to both places. Leaves me with y plus 3 equals negative 1/4 x. Negative 1/4 times negative 4 is a positive 1. Subtract 3 from both sides. I get y equals negative 1/4 x minus 2. Okay? Awesome. Let's flip to the back. We just got one more, a couple more, I guess. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. Okay, so perpendicular, right, means that my slope is going to be an opposite reciprocal. So the first thing I need to do is figure out, well, what is the slope of my shoreline? And the easiest way for me to think about this is I want to find 2 points on my graph, my line, that I know for sure cross at a certain spot. So I can see right here that this point is going to cross at, it looks like 1, 3. And then I have another one over here that looks like it's going to cross at 4, 1. Okay, so I figure out my rise over run here. So I'm going to go down 2 to the right 3. So the slope of this line, down 2 to the right 3. So the slope is negative 2/3. Okay, if the helicopter is flying perpendicular to the shoreline, then that means that the slope for this line needs to be the opposite reciprocal. So opposite would be a positive 2/3. Reciprocal is going to be 3/2. So I know that I need to write an equation with a line that has a slope of 3/2 and goes through the point 14, 4. So I'm just going to use my point slope form. Y minus 4 equals 3/2 times x minus 14. Okay, then I'm just going to do my distributing. This should feel pretty comfortable by now. Y minus 4 equals 3/2 x. And then something that I like about multiplying by 3/2 or 1 1/2 is that you're taking the whole value and then adding half of it to it. So my whole value of 14, half of it is 7. So 1 1/2 times 14 is going to be 21, or 14 plus 7. So minus 21. Add 4 to both sides. I'm left with y equals 3/2 x minus 17 is what that comes to. Okay, the second part about this, or the last part on this one, is another helicopter is at the 0.85. The shortest flight is still one that is perpendicular to the shoreline. So write an equation that represents this path. So we're using still the same model, the same graph, but now instead of having my point be at 14.4, this helicopter is at 8, 1, 2, 3, 4, 5, right here. Okay, so this is helicopter number 2. Is right there. Okay, so the shortest distance is also one that is perpendicular to the shoreline. So I want you to go ahead and figure out what would the equation be for this second helicopter. And then you can come back here and check your answers with me when you're done. Okay, you should have gotten that y equals 3/2 x minus 7. I'm going to go ahead and show you too what this looks like on our graph, right? So here is our shoreline. Let me make this a little thicker. Here is our shoreline, right here. Our first helicopter, it goes through right here. And then our second helicopter is going through right about here. So you can tell, right, that these two lines, the two going right here, these are parallel, right? We can tell that because of what they look like. And both of these are crossing this line at a right angle. So they are both perpendicular to the shoreline.